Great. I'd like to welcome everyone to the third of the webinar series that we had with the Clinical and Scientific Computing SIG. It's now 12:30, so we may as well get started so that we've got plenty of time for discussions towards the end. A little bit of housekeeping before we begin. Like with the other webinars, this webinar will be recorded and available later on the IPEM YouTube channel. So if you don't want your camera to be on and recorded, perhaps keep that off. And if you've got any questions whilst people are kind of presenting, just pop them in the chat and we'll try and do our best to get all of those answered during the webinar. And just to mention, so there'll be, we've got four presentations from four great speakers today. They will be kind of case studying various tools. Those tools are not kind of officially endorsed by IPEM. They're meant to be kind of case studies of kind of people's experiences within the workplace, kind of sharing that. So they're not a specific endorsement by IPEM. So in terms of what's going to happen, we've got four speakers. We've got Robert Ross from the Gloucestershire Hospitals NHS Foundation Trust. We've got James Lees from University Hospital Southampton NHS Foundation Trust. We've got Anthony Carver from University Hospital Birmingham, and we've got Jack Baldwin from the Leeds Teaching Hospitals. So they're going to take a few different, kind of just case study a few different tools, kind of discussing this kind of free versus commercial, the benefits, pros, etc., kind of cons, for their particular case studies. And then we'll finish with a bit of a panel discussion, both in terms of some prepared questions, but also if you've got any questions, just add them into the chat and we can discuss those too. Right, so without further ado, I'll pass over to Robert Ross, who will be talking to us about Redmine.
Thank you very much, Josh. You should be able to see my screen now. So I will begin. So I'm going to be speaking about Redmine, which is a topic I've spoken about before, but hopefully this time with a bit more focus on the open source nature of it. So first of all, why did I look at Redmine? I wanted to implement an electronic fault log system. We had a paper fault log system here in radiotherapy, which was quite hard to read with messy handwriting, usually mine, and carbon copies, and paper sometimes gets lost or was inaccessible if it's in a folder in an office that you can't get into. Electronic fault logs can be backed up. They use typed text, so everything's legible. We can also data mine for fault log trends easily, and we can access the data from a variety of different PCs. We're not tied to having a specific folder or location. So really, we just need a database and a way to enter the data and read that data. So it is possible to do this yourself, but it's fairly standard stuff, and I don't have a lot of resources. I've never written web interfaces before, and I don't have a lot of time to write that kind of infrastructure. So it occurred to me that this must be something that already exists as an open source solution. I heard the Royal Marsden was using Redmine for fault logs. Sorry, I'm just looking at the wrong slide here. I heard the Royal Marsden was using Redmine for fault logs for issue tracking already, which was great because that was exactly what I was wanting to use it for. So I decided to investigate using Redmine in my own department. So Redmine itself is an open source solution, and Bitnami is a company that produced a turnkey solution. So you just download one installation file and run it, and it installs all the various packages correctly for you. So you don't need to install all the various databases, web servers, all the back-end stuff that all needs to be configured appropriately in order to get to useful things. So it was really quick, simple to install to get to a working solution. There is no commercial alternative that I could find that would do what I needed it to do. So the fact that Redmine was out there was quite a good solution. There is no funding available for it. And it's quite nice in that you can define your own statuses. The issues aren't just open, closed, or in progress. So in this example here on the screen, this is from our external beam radiotherapy equipment fault logs. You can see in the status column here, looking at this Redmine screenshot, that we've got statuses like closed and open and QA physics, which means that quality assurance from physics is undergoing, undergoing that process. So there's a variety of different statuses that you can define in there. clicking on one of these entries, you can see some of the more detail that we can record within those. So we can record lots of free text. We can also link to other parts of Redmine in there, so we can connect things together, such as wiki entries and other faults that have gone on. And you can also upload images within there as well, so any screenshots of machine errors. So you can capture a lot of data, far more than you can with our paper system, and it lets you do all this just natively within Redmine. So having gone to a bit of effort to get the fault logs working, it was obvious that Redmine could be used for a lot more than just fault logs. So another problem that we had that was in search of a solution was a clinical status indicator for our treatment Linacs. And using Python and Redmine's REST interfaces, I was able to use Redmine's issue tracking as a back-end system to record an auditable trail of changes to Linux status. And to do that, I wrote in Python a traffic light overlay system that is running on the PC next to the treatment consoles. So in this example here on the screen, it shows you the amber, which says that the machine is okay for clinical use, indicating it's not yet in clinical use, but there are no contraindications to it. And there's a change status button there. So you don't actually need to explicitly log into Redmine in order to update the status on there. You can just use that overlay. And then Redmine is being used to record all the information about which Linac was changed when and who did it. There are lots of other uses for Redmine. It is a fully featured project management tool, so it has inbuilt Gantt charts, and you can use it for monitoring progress on those. So it gives you a percentage completed in there. So this is an ARI upgrade project I worked on a couple of years ago, and these are my Gantt charts on there. So it's quite handy just for a quick visual guide without having to sort of mess around in Excel for trying to generate Gantt charts. It also has an inbuilt wiki facility. And that's quite nice because it means that we can get to this on any PC because it's hosted on a web browser type interface using Apache on a server that's local to the trust. We can just have a wiki. That means any machine that you're on, you can instantly access the wiki just by logging into Redmine using your credentials. And that saves us having to run upstairs and get notebooks, and also allows us to have a bit of peer review. So if I write a wiki entry for how to do something, for example, how to switch on a Linac, then our engineers can review that and make sure they concur. And we can also upload photos into the wiki entries as well. So you see here, I've got a photo of the various buttons on a CT scanner supply panel. So it's really obvious which ones to press and which ones not to press. And it's also nice in that there's a search function within the wiki. So even if you don't know exactly what term you're looking for, you can just keep searching until you actually find your solution. Other things I use it for is logging run-up log data. So again, using Python or Excel as an interface to record the data in Redmine, essentially using it just as like a database, but without having to set up any specific databases within there. And one of the nice things about that as well is that we can pull the data out with Python and Excel for trend analysis, but you can also just export the data from Redmine just using an export CSV facility that's built into Redmine. So you could just download them as CSV files for your own analysis. We also have things like a QA log calendar. We record our archives from our treatment planning system. We never quite know which patient is in which archive, so it helps us manage that. I've got a Python program that reads all the archive files and then makes entries into Redmine automatically based on where the patient is, so we can find exactly which file the patient is in. And these files can be 4 gigabytes big, so they're quite big files to search through. That saves us quite a lot of time. We also use it for recording patient-specific quality assurance results, which is a partially manual system and partly automated data entry from our treatment planning system into Redmine. So we use it an awful lot within our department. It really is an incredibly useful tool that saves us a lot of time and effort in developing database applications and worrying about interfaces. But there are some concerns about it. Bitnami no longer produce their turnkey solution, so that really simple one installation file no longer exists. So they stopped making it on version 5, and now they're on version 5.05. And there's a couple of bugs in version 5 which haven't been addressed in the turnkey solutions that are available, and they seem to no longer make it. No one else makes the turnkey solution as well. They've moved on to a technology called Dockers, which is a little bit like virtual machines. Virtual machines are available as well. And the difficulty with those is that my trust doesn't support Dockers or virtual machines, in fact. So moving forward to the new version of Redmine to upgrade it and maintain it in order to make sure I'm using the latest version of software for security purposes and to benefit from the latest features, that's going to be problematic. You can install Redmine manually, but again, it is more labor intensive. There's lots of different bits to install. Have to make sure they're all working right, and you have to make sure you've got the right versions for all of those different bits. And Redmine runs on a technology called Ruby. And I'm having trouble on a new server. We've got an old server that currently runs Redmine, and that's deprecated. It's meant to be being out of service next month, but I can't seem to run Ruby on Rails on our new server, on the new version of Windows that we have on there. So that's an ongoing issue. So what is the future of using Redmine for our department? The truth is, I don't really know what that future is going to look like. I am working with our cybersecurity and IT teams to try to get Ruby working on the new server. I will be having to look at installing it manually because I don't think I'm going to be able to find any Dockers or virtual machines that are going to be supported by the trust. And ultimately, if I can't do any of those things, I'll be running Redmine on a PC on a desk on a UPS, which is not a great solution and a retrograde step from having to use a server to go back to a PC and running version 5, which eventually will fall foul of various compatibility issues with Windows 10 and of our security systems as it's running older versions of Apache and MySQL as those technologies progress in future. So that's all I've got to say on the matter. So I will hand you back to Josh.
Thanks very much, Robert. That's really interesting. If anyone has any questions for Robert, either pop them in the chat or put your hand up with the raise hand feature, and you'll be able to ask your question. I did have one question. Just so it looks like you've done quite a lot of work just expanding this for the department, and actually it's becoming more and more reliant on this kind of software that you've kind of really kind of got to know the nooks and crannies of it, kind of thing. Like, what was there kind of at the beginning was it just, oh, let's give this a try, or did you do a formal kind of assessment of what was out there, both commercial and free, and then opted for this particular solution? Like, how did that process work for you?
It was a little bit of both, really. It was kind of, we had to see what was out there and what would work. And there really isn't a lot. There wasn't a huge amount of options to go through. I contacted our Trust IT to try and do it officially, and they suggested using Topdesk, which is what they use for their issue tracking when you raise a case. Like if your Outlook isn't working, that's what they use, but it's very limited in terms of it is just issues and it's just sort of open, closed, or overdue. And we had very little control over that because it is the IT solution. We would have very limited access to it. And it didn't have things like being able to interface using a REST interface in Python. And there aren't many of these systems. There are a few more out and about now, but various levels of complexity. And that turnkey solution, that single file installation, was such a big boon for using Redmine. And also the fact that Royal Marsden had already done it. They'd kind of already done the proof of principle that it would work in their departments for it. And I know other sites, other trusts have started using Redmine for the same kind of things as well now. So it really does seem to be, the most obvious solution. And we just thought we would try it and see and move to something else if we found it didn't work for us. But it's been over 4 years now, and it's been, it's been great, I think. But just starting to fall a little bit foul of changes in technology now.
And how has how's it been kind of accepted within the department amongst different staff groups? Is it something that everyone's very pleased with and kind of sees the value in, or is it something you've had to persuade other staff groups of its value?
Depends on the application for it generally. The clinical status indicator, people tend not to engage with that as much as they maybe could do. We're looking at updating that process, but it's more about, they don't see that as Redmine. It's more about what the statuses are. So it's more about the actual application of it. The biggest compliment I get about Redmine is that no one complains about it. People don't tend to say, this is a really good application. What they tend to say is, oh, that's a really bad application. So the fact no one ever complains about Redmine, or very rarely complains, and when they do complain, it's usually something like, I've set a setting wrong in it. So it tends to be my user error, or something to do with how I've defined the workflows, rather than any fundamental issue with Redmine.
That's great. Thanks very much. There's a question in the chat here. So How do the instructions on the wiki fit in with kind of control documents procedures, and how easy is it to keep the wiki up to date and correct?
So occasionally with control documents and procedures, they can be very hard to update because they have to go through a formal ratification process. So my take on it is the wiki is always stuff that is kind of things we would note in our notebooks. So we do have control documents and procedures as well. Some of the content is replicated. So literally I'll just copy and paste out of the control document for a few things into the wiki. But mostly it's the sort of stuff I would have in a notebook that isn't necessarily already featured in a control document and procedure. So it's not things like how to do LINAC outputs. It's more things like, if you get this interlock message, this is the action to take, even if that action is simply call the engineers. But it could be a case of it's a rare interlock that we can reset, but we don't see it often enough. And you can just type in the interlock message and it tells you what to do. And our engineers are very good. If I say, I've made this wiki entry, can you review it for me to make sure it's okay? They will do that and maybe make a few comments or corrections on it. And that means everyone's doing the same steps rather than us all having our own notebooks that are maybe I've taken one thing and they've taken another thing away from what we were told. So yeah, it's good there. Thank you.
Thanks very much, Robert. So we'll probably move on now to the next speaker, which is James Lees from the University of Southampton, and he's going to talk to us about the Atlassian kind of tool set.
Thanks, Josh. I'll just try and get the right window shared and then I will get started. Thanks. Can I just check you're looking at a title slide?
Yep, we are.
Perfect, thank you. So following on from Robert's talk, I'm going to be talking about sort of similar-ish tools, but a commercial solution from Atlassian. So taking you through the kind of the market appraisal type journey that I went through, and then picking why we went down the route that we did, and then finishing up with some reflections, a bit like Robert's taken us through with Redmine there too. Quickly, our SciComm team in imaging physics at Southampton, our specialism is largely in producing custom clinical research software for those niche applications where commercial solutions don't fill that gap. So it's largely producing medical device software with a specialism in medical imaging, sort of decision support and reporting, but pushing outside of that through a few other types of data to beyond imaging. So we've got a few bits of core infrastructure that we've developed and implemented by our team. So they're obviously not developed, but the Atlassian tools here, we've got our Bitbucket, Jira, and Confluence. I'll talk a bit more about what we use those for as we go through the slides, of course, and then we've got a few add-ons to those tools, which we can get X-Ray for managing our test processing, and Kamala approval workflows for managing our document review and approval processes. And then a few other bits that we've got in the team. So we use XNAP for as a repository for imaging research data. DICOM Broker is a tool that's developed within our team for managing, if this then that type work. So if we receive certain DICOM files from certain places, then it knows what clinical processing to do. So it then calls that processing and sends it on to where it should do. That's developed in Python within the team. But then sort of other standalone clinical tool deployments, as I said, the sort of things that we produce in-house. So the Atlassian tools we tend to interact with through the web, but then of course our Bitbucket server will interact with through Git as well for our version control for the software. So why quality management tools? Well, there's a few things here: enhancing our own reputation and image, but most importantly for us really is sort of improving the way that we work, reducing those inefficiencies and improving quality. The thing that I always come back to is this quote from BSI that a registered 13485 system is recognized as proof of a QMS for CE marking. So this was our kind of core sort of carrot, I suppose, for going down this road for implementing some sort of quality management system and set of tools. There's some information here about that QMS from a very high level. The way that we went down this was starting with sort of Word document templates, starting with what we're good at, which was problem solving and developing solutions to fill these gaps. And then alongside using Word documents to build up that process, I started conducting a sort of market review and procurement process for a digital QMS or document management system, which is what this talk's going to be about. The options that I looked at were the Atlassian tools that we've talked about, either in the cloud or self-hosted. QPulse, which I'm sure many of you are aware, which is self-hosted within the trust. So it's already used for an ISO 9001 QMS within medical physics and other places throughout the trust. So there's use there. Redmine, I'd heard about this from other talks, and this process that I went through was around 5 years ago. I think there'd been some scope articles, and there was a talk at one of the previous ICSIG meetings about it. And then GitHub, somebody in the department had already started exploring using GitHub in the cloud for our version control. So these were the options that I reviewed, and given by the title of the talk, you can probably work out that what we went with as a team was using Jira, Confluence and Bitbucket, but we decided to self-host these, which I'll talk a bit about why too. The key considerations in this appraisal, so apologies, a few text-heavy slides, but cost, of course, both initial and ongoing. Maintenance, again, both initial and ongoing, so there's some sort of setup overhead. But then there's also, sort of bug fixes, security updates, keeping things going, but also making sure those tools do the functionality that we need them to, considering whether that would be available out of the box or if the tools would need customization, would we need to write scripts to interact with an API, apologies, and that sort of thing. Data security and business continuity, two key elements here. So, backup requirements, hosting locations, so where would we host it within the trust, or if it's in the cloud, where does the data go, what sort of SLA is there for uptime and that sort of thing. And then, importantly, the actual functionality. So I went through a few user stories with different groups on how they would need to use the system and what they might use the system for. So why Confluence, Jira and Bitbucket? So this first slide is just some different places that I'd heard had used this. NHS Digital using it for their own software development in-house. I'd done my STP training at the Royal Surrey where they'd used some of the tools there, so I had some prior experience. UHS Digital, our informatics team, use it for their service desk. They run Jira on site too. And then some other places that we'd had or where colleagues had worked before. So Diamond Light Source had used it previously too. And then I'd sort of borrowed a logo here from Atlassian themselves, but discovering that it was so widely used across so many different industries as well just gave it a little bit of a boost, with some being from healthcare and elsewhere. So why self-host? One of the biggest problems was the risk of patient identifiable data being uploaded to the cloud. So somebody might just screenshot a report that's a clinical report produced by one of our tools and just upload it without thinking because they found a bug. And it was very challenging to work out how we would mitigate that risk. Ensuring external network issues didn't compromise access and bring down our work as the team, because we were planning on implementing this as a very core tool to all of our work. The self-hosting, the plus is probably a negative of this, is that issues with developing for macOS or developing for iOS if we need to do that on a Mac, or off-site development is challenging and remains challenging to this day. If we need to get code, which obviously won't have any patient identifiable data in it, to an offsite repository or working from home and that sort of thing. We could use LDAP, which meant we didn't need to avoid creating more credentials for people to remember. And we also were able to deploy it on an informatics managed virtual machine. So we didn't need to worry about hardware maintenance for the servers that we were running these things on. In terms of connectivity, this is a huge plus, and it's something that we get a lot of positive feedback on. So we can link requirements or hazard mitigations in a Confluence page or in a document to a Jira issue, which is the project management or issue tracking tool, and then track work against that. And then we can link that to individual commits and line by line changes and pull requests or code reviews for to and fro between different people and look at that conversation. So there's this really nice linked audit trail through from documents to issue management to code changes, and it's all then sort of got user information tied to that too. So you can do who did what, when, why, and how to meet different needs. Collaboration is fantastic in these tools. So multiple staff can edit documents in real time. We have real trouble with this in Word and in Teams, so you have to wait 5-10 more seconds for updates to happen. It just happens instantly in Confluence, which is really nice. The code review process in Bitbucket works really nicely. I'd thoroughly recommend that to anybody who's trying to implement that sort of review process on code. And Jira has really nice task management, test management, also reporting tools. It's got a lot of reporting built in. And you can also use Jira query language or JQL to write your own more powerful queries if you wish. And kind of the theme that we wanted to run through on this was to make everything open and accessible throughout. So this isn't open source, this is information being open. So we could do that, but we could pin down the access control when required. So a lot of our documentation is fully open without login across the trust. If you want to look at it and read certain pages, then you can, which I think is an important safety element for this. But equally, there are some things where not everybody kind of needs to see your line by line code changes to meet Jira issues and that sort of thing. So some of that we can lock down a bit more if need be. So I've just got a couple of slides of reflections here as I come towards the end. So we do this currently for 16 medical device applications and more non-medical device tools that we've worked on. So we keep the documents, we keep the code repositories, the issue tracking. It's definitely increased the accessibility and shared understanding of our software. So as we hand things over between people or pick things up after a staff member has left, it's really definitely helped with those handovers and picking up work. We've managed to create an excellent framework for managing clinical safety cases and hazard logs, both for our own tools, non-medical device, as well as medical device. But that then has picked up a reputation for other things across the trust and then across the region. So this was used for the clinical safety case for the Hampshire and Isle of Wight COVID saliva testing service, and is now being used the same for the South Coast Pathology Regional LIMS implementation project, working with a few other industrial partners. So that's worked really well, linking Jira issues to hazard logs and that kind of thing is nice. The server-based deployment means we don't have those maintenance, it means we don't have the hardware maintenance, but what we have noticed is software maintenance overhead. So we need to roll out the updates, which means we are considering moving to cloud, but obviously with those other implications. I should say the support is generally quite good, but it has varied. We have had some support from NHS Digital in the past because they've used these tools, but also a bit surprisingly, some of the issues have required directly editing the Postgres database run underneath. And of course, it's worth mentioning that these tools do tend to rely on open source under the hood. I realise I think I'm over time, so I'll just talk through a few of these quickly. But the QMS itself, which isn't really what I'm talking about as the main part of this, has been a lot of work, but we have seen visible quality improvement, which I think wholeheartedly makes it worth it. A couple of points here then around the Atlassian tools. It's really easy to overlook the resource for ongoing support, but Jira allows us to maintain and highlight a list of devices, including the QMS tools in those support phases. So it helps us highlight the kind of increasing maintenance burden, I suppose, of the devices that we put out, because Jira allows us to automate some of that reporting. And then finally, I think a really nice bit of feedback we had was from the BSI auditor on our 13485 stage 1 audit. And she was just so impressed at how quickly we could pull back the documents that she was asking for SOPs or records and things like that. Yeah, that's the end of my talk for those tools. So happy to take any questions.
Thanks very much, James. It's really, really interesting. Again, if there's any questions, either pop them in the chat or just raise your hand on Zoom, and we'll get those asked to James. One question I had was how much, it looks like the system is really effective. The fact that it's been then used for lots of other things. How much customization and how much time did it take to be able to get it into to meet your workflow and your life cycle, etc.? Did that take a long time, or was it actually very straightforward?
To be honest, we've done it over quite a long period of time as we've learned the processes, built up the QMS over those 4 or 5 years. So it's not the easiest question to answer. I've always said, I think the biggest negative about these tools is that they can almost do too much. So there's so much configuration that you can get into. Take Jira, for example. Jira at its heart is based on issues moving between states through defined transitions. You can create whatever states and transitions and workflows that you like for those moving through, and then you can create triggers or transitions for those different. So as you're moving between an issue, you can create a trigger that will update a field, or you can do essentially what you like in it. You're building a database almost from that what you see is what you get editor. So I don't think it's taken too much work because we could spread that out. You don't need to write any code to be able to configure most of this stuff. But again, we obviously have configured it quite significantly over the past 4 or so years to be able to do that. What I would add to that, though, is for those regional projects, we've used the cloud system for that. And because of their nature, they always tend to need setting up very quickly. And as a result, where they haven't had anywhere near as much configuration, but they've still worked fine. Yeah.
Thanks very much. That's really, really interesting. We don't have any more questions in the chat at the moment, but feel free to add them in, and we'll ask again after the rest of the talks. So we'll move on now to the next talk, which is by Anthony Carver, who will be presenting on an anonymization tool that he's been working on. So I'll just hand over straight to him.
Okay, hang on. I'll just share my slide. Can everyone see that?
Yep, we can see that.
Cool, brilliant. Yeah, okay, so I'm going to talk about the anonymization part of our platform Propel. So I guess many of you have probably heard me talk about the rest of Propel at various other talks over the years, but today I will stick to the anonymization functionality. So for the Sabre CTE commissioning program, the DICOM data were collected centrally here at Birmingham as part of the analysis. One of the key requirements was that the DICOM data were stored anonymously. So as part of that, we required an anonymizer on the import pipeline into Propel. So that's the story. So requirements. So first and foremost, anonymize the DICOM data as specified in the DICOM standard, chapter 15, I think, from memory. It's been a while since I've looked at it. One of the more interesting requirements is to consistently recode UIDs. So we didn't know when data were going to be uploaded and had no particular reason to think that the data for a given patient would be uploaded sort of all together. And also we didn't have permission to store identifiable data, so we can keep the UIDs or can keep the DICOM data. So we wanted a tool that could consistently recode the UIDs without needing to keep any sort of mapping table or database or cache the data for any longer than necessary. And ideally, we want to be able to conditionally anonymize. So, for example, some systems store private tags that might be useful for analysis, but in other platforms where you didn't necessarily know if anything was going to be squirreled away in that private tag, you wouldn't want to keep it. And it needed to be automatable. So we recruited over 2,000 patients into the CTE study. So we didn't want to have to manually anonymize them. And little or no cost. So we didn't have any specific funding for purchasing a new anonymization tool. So the options appraisal was largely limited to free tools or those we already had, such as our existing Anonymize for clinical data. So what were the options? So we did have clinical tools that could anonymize. So we have Pucka-J, which we used historically for anonymizing clinical data for training or clinical trials or so on, and some other clinical software such as planning systems. I've not put Monaco down, we had that at the time. RayStation, other tools we could explore such as Prosoma. And then the other half was tools you don't have to pay for that we didn't have, so open source tools predominantly. I've listed the two here, although there are a lot more. So Orthanc was the DICOM server that we used as the backend for the CTE project. So that does have anonymization functionality built in. And there's also a library called GDCM, which stands for the Grassroots DICOM library, I think. And that also includes anonymization functionality. And I think plenty of the other ones do as well. So the reason I listed GDCM was, in the end, we went for GDCM because it had quite a powerful anonymizer already built in, or already included in its source code that we could modify relatively easily to do what we needed to do. So you can create a list of tags that you want to be modified or removed or changed. So that was quite easily customizable. Like Orthanc, it was written in C++, so it's relatively easy to link the two together to create an automated pipeline to share data between Orthanc and GDCM. We did have to add the consistent UID recoding. There are plenty of tools out there that will recode UIDs, but the ones that I found, I don't know if there's others now, this was some years ago now, used some kind of mapping table, or they were storing data to do with the previous case to perform the recoding. And obviously, being an open source tool, it meant that we were able to meet these requirements quite easily, because if it didn't do what we wanted to do, we could make it do what we wanted to do. So yeah, as I've mentioned, really the key requirement that was the reason we ended up using an open source tool, along with the automated pipeline aspect, was UID hashing. So you probably know the UID consists of sort of two main parts. You've got the org root, and then you've got the rest of the UID that is largely up to the system how to fill, subject to certain requirements that are specified in the DICOM standard. So we have a UID string for Birmingham. So that kind of defines the first 12 or 15 characters or something. I can't remember how many, which leaves you with however many that was, up to 64. So for that, we took the hash of the existing UID using a keycac hash. It is actually cryptographically quite secure. It's going to be SHA-3 or SHA-2 ever falls, but that wasn't why we used it. The reason we used it is that it has variable length, so that you can tune it so that it fills however many characters there are left, and then there's a little bit of tidying up to do to make sure you meet all the bullet points in the standard, but that's the core of it. Yeah, so that was our project, and that was why we went with open source. Thank you.
Thanks very much, Anthony. That's really interesting. A good example of kind of going a particular way for a specific kind of project. Are there any questions from anyone in the chat for Anthony? I can't see any, so I think in the interest of time, we'll move straight on to the next presentation, which actually is very relevant as well, because this is using one of the examples that Anthony's just mentioned in terms of Pucka-J and being a commercial solution. So we'll be able to kind of see the two sides of one going open source and one kind of using a commercial system. So I'll hand straight over to Jack.
Thank you very much. I'll just quickly share my screen. Can everyone see that? Just make sure everyone can see.
I can't see it at the moment.
Because I haven't clicked share.
Can see it now.
Perfect. So yes, I'm here to just basically talk about the commercial side of this thing, and this is using a product called Pucka-J Nexus. So it's an extension on the original, the older sort of Pucka-J anonymization engine which they produced. Now, we commissioned this for both clinical and research use. I'm not going to touch the clinical side of things. This is mostly focusing on the anonymization side of things. So basically, looking at the previous solution, looking at the Pucka-J anonymization engine, and just sort of the different things we had, why did we need a new solution that was this Pucka-J Nexus solution? And what we used to have was a DICOM store with auto forwarding rules. That's what the original Pucka-J anonymization does. It's just a normal standard PAX-like DICOM store with an auto forwarding rule that would forward things to our research environment. Now, this had very limited tag de-identification rules. You could either only remove, replace certain tag ones or empty tag twos. I'm not going to go into a huge amount of details about sort of the ins and outs of DICOM, I'm afraid. If you want more information about that, just let me know and I can sort of give you some more information. and it had a single anonymization lookup table for study IDs. So if we had multiple studies, we have quite a lot of studies going through Leeds, they would all have to, each patient would have to share the study ID. Otherwise, it didn't like it because it had a single trial ID. It was like the anonymization engine. And this gave us very limited study ID de-identification options because, like I said, you had a patient with one patient with multiple, or in multiple projects with the same study ID, which is not good practice when it comes to research. Also, these study IDs, but the way the anonymization engine works is that you've got a single like CS4 uploaded CSV file. That's all the study IDs, so it's readable by any of the research users. So again, really, really bad practice. People in different research projects can see the lookup table for the study ID to patient ID table, which again, these are clinicians, they shouldn't be doing this, but it gives them that option, and it's not good practice. It also stores data unnecessarily because this is a DICOM store. Data store sits there for about 30 days before it gets aged, so it's a waste of resources in terms of storage. Like I said, it dates every 30 days, but this is still not good practice. And it requires significant user interactions once set up. Once you've set up these pipelines, it's very manual. You even have to go into PuckerJ and right click and move to the anonymization engine. So it's not the easiest thing to use. So what we decided to do is we looked at, PuckerJ had released this new product called PuckerJ Nexus, and we looked into it, and it looked like a really powerful tool. It's a web-based tool. You sort of go to a website and you can access it there. You build it almost like a LabVIEW style GUI-based programming where you pick different nodes throughout it, and each different node does different things. But as long as you've got a source and a destination, you can sort of do what you want in the middle. And each of these individual pipelines is a separate entity which can't interact with the others. So it separates every single research project. And we've put about 14, 15 projects through the past couple of years. So it's been really sort of expandable in that regards. If we look at the anonymization, example anonymization pipeline, you've got a store SCP, so just like a DICOM store listening to things being sent to it. You then have an anonymization node. We can then filter, split things up. So we've got RT structures and RT doses going one way, our CTs go another. This is because RayStation treats a type 3 tag as a type 1 tag. So we have to, and our CT sims don't. So we have to add, we've got something in place to allow us to add a tag. So we can edit the tags as they go through, and then we can save to a folder. So again, we don't need an SCP listening. We don't need a service listening. We can just save it directly to our secure research infrastructure. We look at what we can do with it. We can sort of set some default options. The key one here is we can remove or keep private tags. If we like I think as Anthony mentioned, that sometimes private tags has useful stuff, or we can just remove them all. And the key one is the ReUID. And because we've got a lot of projects going through this, and each project could have the same patient going through, we want different UIDs going through. And the problem with hashing, I find, is that when you use it, it creates the same UID every single time. Now that's great if you've got a single project, but with multiple projects, we don't want to be able to link two projects together via the UID. If you stick these two projects into the same system, most PACS systems will link them automatically. So we want to avoid that. So what we do is we store on the back end a lookup table that links a trial-dependent ReUID with the original UID. And finally, because PuckerJ is a DICOM supplier, they generate a compliant UID. This is a globally unique UID. So another issue I find with hashing is that technically it's not globally unique. You could, by random chance, it'd be rare, but you could find it in the wild somewhere. So by having a official DICOM supplier, we get around this problem. We can then, like I said, this is very similar to the original anonymization engine. You can remove tags, you can replace tags, you can empty tags. For every single tag you can go through. We can also set up anonymization lookup tables. And again, these are project specific. So each of these nodes is a different research project. This is like the defaults. This is the dummy data that comes with. This is not identifiable, which is why I can show it to you. But you can see that you give it a bunch of different things, including things like date of birth and gender, so you can anonymize these on a patient-by-patient basis. It's also got a built-in CMove controller, so you can give it either a cfind request or a list-based controller and say, I want these 200 study series UIDs, go get them for me from another PAC system. So we can automate the extraction as well, much more powerfully, which is really quite nice. The key thing, though, that really sold us on PuckaJ Nexus is the purchase came with dedicated development time. So we worked with PuckaJ to have additional features added to the product. And 2 of these have been completed. The first one is an external SQL server linked to the anonymization lookup table. So we can link this anonymization lookup table with our backend SQL server, giving us a lot of power in being able to automatically update our anonymization lookup as new patients come through for a study. We also got patient-dependent tag substitution added. This works when we've got things like, let's say you've got re-radiation study, or looking at XVI, like daily scans. The doctors or the clinicians or the researchers want the time dependence, but we want to remove study all the dates and times because it's, again, good practice. So what we can do is we can set the first image to the first 1900, and then add the correct number of dates for each like next scan. So you can preserve the time dependence, but still de-identify this data much more rigorously. Finally, what we're currently ongoing is an automated PACS query retrieve service. So we can have our SQL server, reporting server, monitor our patient cohort. So as a patient comes in, it can be picked up by the SQL, the data warehouse. This can then automatically query the PACS services for all the images for that patient. We can then filter that out by what patients are relevant for the study. That can then be sent to the anonymization lookup table to be updated for that. The patient-dependent tags can be updated, and then we can put a request in for a query retrieve to move things through Nexus. And we can automate the entire process. And we couldn't have done this without the dedicated time that we came with the purchase of PuckaJ. Now, PuckaJ obviously gets something out of this. They add it to their product. This anyone who buys Nexus now gets these features, but it really means it allowed us to customize the product. So some advantages, as PuckaJ is a DICOM supplier, we get brand new DICOM UIDs, like compliant DICOM UIDs with each research project, minimal storage costs. These things, it's a pipeline, it's not a store. So things are stored for as most a couple of seconds as things pass through. There's no stored, very, very limited storage costs. It's highly customizable. I haven't gone into detail what nodes you can do in this, but there's a lot of interesting nodes. Particularly, there's an execute node. So you can put Python code into this and execute Python code as it comes through, and it will update DICOM tags. We get very good ongoing support. PuckaJ is quite a small company. We've got a very good working relationship with them. I drop them an email, I get a response very quickly, and sometimes even jump on a Teams call with them just to go through the problems. And like I said, the purchase included dedicated development time, which has been invaluable. Some disadvantages: it's got a very sharp learning curve. It's very fiddly. It does sometimes feel like a bit like an open source software. There is some things you need to learn. It does require the version we have requires experience with Linux. You have to get into the Linux backend to open firewalls or manage the MySQL server, which is a bit fiddly, but it's unfortunately that is a disadvantage. And PuckaJ do admit that documentation could be a lot better. It's not got the best documentation. They are working on it, but it's not great at the moment. Yeah, it's probably one of the biggest disadvantages. And the only disadvantage we had with the development time is it depended on generalizability. There were a few cases that we had that they said no, that's not really viable because it couldn't be generalized, or they took something we wanted to do and made it a bit more generalizable before implementing it, which means you don't get perfect customizability. That is one advantage of open source, but we get some, and I think that's really the takeaway here. So thank you very much. If there are any questions, Brand, if not, I think we can go straight onto the round table. Thank you very much.
Thanks very much, Jack. That was really interesting and good. Thanks very much. Really interesting. Good to see a different kind of approach to kind of solving the same problem. Are there any questions from anyone for Jack? Okay. There's nothing coming through at the moment, so if you do think of something, feel free to pop it in the chat. But I'll invite all our speakers back now, and we'll just put a few questions to them, just thinking through some of the pros and cons of kind of working through kind of open source or commercial, kind of dealing with commercial software. So a question for any of the team are about to start on a project where open source is an option. What are some of the big things that people should be considering?
Hi, Josh. Shall I kick off?
That'd be great.
Yeah, I think there's quite a few things to consider. I think the open source licensing, whether it actually covers using it in healthcare settings or not. I mentioned in my talk about using Dockers. There are open source Dockers available, but they are not available for our kind of use, which could potentially be considered commercially because it would be benefiting us, not necessarily selling it. But there are licensing concerns around there, which I don't know if we always consider how closely people read the licensing agreements. You obviously need to consider the environment your open source is working in and what changes to your environment could come up. What happens if you upgrade servers or Java? What support is there going forward? So Redmine does have a lot of support as a community, but not necessarily from the Bitnami turnkey solution. Do they have a big development team or a small development team? There's been other projects I've worked with open source, things like OpenREM, which was an NHS-based dose monitoring system, and IQWorks is another one. And those ones are very small teams developing those, and the sort of developers have moved on or not got enough people to support moving to the newer versions of Windows and infrastructure. So those kind of fall foul a little bit as well. And also security issues. I had stopped using OpenREM for dose monitoring because it used an older version of, I think, a web interface. I don't remember if it was Apache or something, but I was told by a cybersecurity team I had to get rid of it because it was no longer secure. So I had to write my own open dose monitoring system. But I think the key thing for me is all these points aren't unique to open source. They exist even with the paid software. I mean, we use Pinnacle as our treatment planning system, which uses Oracle Virtual Desktop Client, which hasn't been updated by Oracle since 2013. So although we're paying a support contract for Pinnacle, we have a lot of issues with this product. The Oracle Virtual Desktop Client is not compatible with Windows 10 hugely, and using it over Citrix is more problematic, and it's a key piece of software. So although we're paying for the support, we still have these issues. And of course, we're very reliant then on the vendors and having those discussions. So I think that's definitely a key take home with the conversations we've heard today as well, is that people are talking about the support from the commercial ones and the lack of support from the free ones, but there's not always the support available even with the commercial.
Yeah, thanks very much, Robert. Yeah, that seemed to be something that was kind of, I remember James saying that the support was perhaps on and off sometimes with for example, the Atlassian products. So not necessarily guaranteed. James, do you want to say anything on that?
Yeah, I would echo that. I think support contract doesn't necessarily mean you're going to get things fixed. I've definitely had the response from Atlassian. Yeah, thanks for finding that. We'll put that in our roadmap and consider that for future. I've also recently had an experience with MathWorks and MATLAB where I wanted to display a number to 3 decimal places rather than 4. And they said, no, I'm very sorry, there's no way of doing that. We'll consider that for future implementation, despite the fact we pay thousands a year for MATLAB. So I think, open source and commercial, you still may have the same issues with a sort of a support contract. I was also just thinking that if you're thinking of going down the open support route because there isn't the funding available for a commercial or something like that, then it's worth considering whether or not it might actually make more sense to create your own solution at the end of the day, because it could be that your open source just stops getting supported at one point, and if you don't have the skills required to develop in Ruby on Rails, or I'm not picking on Redmine in particular here, or whatever technology it is, then I don't think it's completely off the table that maybe at the start you should consider developing your own solution from scratch in tools that you do have the experience within your team for.
Yeah, thanks very much.
If you don't mind me, adding to this, I think when you talk about not having the funds to purchase a commercial piece of software, sometimes that's true, but then that's not taking into account the internal support needed, or the internal development time, or the internal monitoring of the product long term. We've just had one of the big projects that one of the first projects I worked on at Leeds was replacing a system that an open source system that failed, and the team had retired, and there was no documentation, there was nothing there. So then sort of I had to replace it with a new product. So there is that risk that the hidden costs might be there. So then the other thing I was going to mention in terms of open source software to be aware of is things like what the dependencies are of the open source software. With the commercial, if you got commercial, they generally lock down products so that they've got like internal versions of libraries. But there was a case a few years back where like 90% of, I don't want to say it was Java, failed because or it was some coding language failed because a open source developer pulled their product from the library because they got annoyed with the community, and they pulled their product, which seemed like it did nothing, but every piece of software depended on it. So everything just fell down. Log4j, yeah, that was more a security issue. This was something else.
It was npm. It was a JavaScript dependency. But I think that's quite that's quite a JavaScript specific issue, isn't it? Where people pull things in real time from npm.
Yeah. So yes, yeah.
Yeah. Okay. So potentially there's the assumptions we make either with things costing much or not costing much, or the support or not support, perhaps aren't as clear cut as being, perhaps the assumption is open source, you get no support, and but it's all free and doesn't take any time to implement. Whereas often perhaps those assumptions aren't necessarily true. So we need to think about that. There is a question around. Do you have issues with your wider Trust IT when it comes to kind of installing non-standard software, in particular around kind of open source free software? Is that more challenging than just kind of commercial software, or is it the same challenge for both?
It very much is an issue, and I think it's getting more so as trusts get more aware of cybersecurity and potential issues. And as well, I think as IT gets more powerful, they do tend to see themselves as the people who do computers, and that the rest of us don't. The rest of us are end users who use Office products, whereas us in medical physics and clinical engineering tend to be a little bit more technologically involved and have specialist needs that IT don't necessarily understand. When you do sort of talk to them about these things, they do want more of a formal project proposal and review, and they do have concerns, which are valid concerns. I don't doubt that. But again, when there is no money, and they'll say things like, well, we can't support this program written in Python because we don't do Python. It's like, but I don't need you to support. I know Python. I can support Python. So it is more difficult. And also things like some of the stuff's blocked. Sometimes the servers don't have internet access now, so you can't download files you might need to install things. May not have enough admin rights to install things. Opening ports, those sorts of things get blocked. And also, like I said earlier about OpenREM, is that if that program doesn't get updated with the latest versions of Apache web server or whatever, then it can fall foul of the IT security scans. Then you get told you have to get rid of it, but you don't necessarily have a solution in place. It can be a very tight turnaround to have to get rid of software and come up with a solution to replace it, which again means we need better conversations with them, but you kind of expose yourself to a can of worms, and there's risk exposing what you're doing to IT because they can shut down what we're doing, and then we lose all that innovation.
Yeah, is that experience that Jack, James, Anthony, that you've also found?
What I would say from my perspective is there is a huge amount to be said for building up excellent relationships with people in your Trust IT or informatics department. We don't have any of these problems, but what we've done over the past sort of 5 or so years as we've built the team and our scientific computer team in imaging physics is build up relationships with key people in the networking team and the IT support team and through forming the QMS that we've built for medical device software development is a partnership with our informatics department, and in doing that, we've built up sort of good links and reassured them that we at least vaguely know what we're doing. So we have that level of trust that we can, we get a reasonable amount of freedom to do these sorts of things.
Is that something, James, that has taken kind of a long time, kind of coming over the initial discussions of kind of, who are you, why are you doing this kind of IT stuff, to then being able to build up those relationships, presumably?
Yeah, I mean, I've been there I think I've been in the team for about 5 years now. This sort of conversations and work didn't start when I started. It's been going on for a while with my line manager, Matt Guy, kind of building up that relationship before I started. So I think it has taken a while building up those contacts and relationships with the sort of important people in the department.
I guess that's easier perhaps for a group where that's a bit larger. For the smaller ones, perhaps embedded within other specialisms, that's perhaps a more challenging thing because they're seen as a very small group compared to the wider trust. Perhaps.
Just on that, I fall into that latter group there. And one thing is we used to have those very good relationships. We knew the individuals. I knew the individuals very well. But then as the trust has become more cybersecurity aware, brought new people in, a lot of people left post-COVID in IT because they could get other jobs elsewhere with remote working. So there's a lot of turnover, a lot of changes, and a lot more upgrades of security and infrastructure. So it is basically starting again with those relationships. And we don't have a lot of pull with them because the IT is very, very strong in our trust in particular. So there are going to be these local variations in how much you can actually do.
We were quite lucky that when the scientific computing team was founded at Leeds, it came off the back of our radiotherapy technical services team that's been there for years. And they have a clinical computing team who manage all the computing for radiotherapy physics, including the servers. So they had a good working relationship with IT, particularly in terms of like data comms and the networking side of things, and having the dedicated hardware, the servers, and being able to build VMs on those servers ourselves did give us some freedom. We were lucky in that regard, but then now we're having to keep making sure that we keep that good relationship. We try and maintain it, and try not to do anything too wild out of the blue, just because we don't want to annoy anyone and things like that.
Yeah, thanks very much. One last question before we finish. This is perhaps a difficult one to answer, but we've talked about kind of buying software or kind of developing your own software or using kind of in-house, open source that kind of is already available. Do you think is collaboration through open source kind of within the health setting, within the NHS, for example, is that a reality, or is that just simply not achievable because of the kind of other barriers for implementation, different trusts or medical devices, etc.? Is the open source approach where we collaborate together, is that feasibility in the future?
I think the big sorry, Robert, I think the big one here in terms of collaboration, I think for non-medical device software, I think there is sort of opportunities, but the second it crosses the barrier into becoming a medical device, what could be because we don't know what it's going to be yet. It's not fully in place, but the current understanding is that future medical device regulations will require CE marking unless it stays in a legal entity. And obviously, because of the trust system in the UK, each trust is its own legal entity, and therefore we can't share stuff without paying. I think it's £3,000 upfront and £1,000 a year for CE marking software. So that's always going to be a barrier for clinical software, medical device software at the very least.
Any other thoughts on the panel?
Yeah, I think I would echo sort of what Jack said there. I really think it could be very powerful for the trusts to work together on open source software to build those collaborations. I think it could be really exciting to work on those kind of projects, but I suspect for medical device applications, certainly with the regulatory framework we have now, I mean, who knows how that's going to change over the next few years, but I think with the way it is at the moment, it's largely going to be impossible unless sort of NHS or improvement. I can't remember exactly how their structure is at the moment, but unless they come up with something central, but even then I think it's going to be more challenging than it's worth to set something up there. But I think on non-medical device projects, I think it could be really quite powerful and exciting, and maybe this is the group to lead the way with that.
I agree with what's been said. There have been some efforts on it, like OpenREM, which I mentioned earlier, is actually a collaboration between various people, which has been made open source for free. There's no legal entity. It's not a medical device because it's only dose monitoring. It doesn't affect anything. But the big barrier really is that we don't have enough staff working in the field. We've got more work than we can cope with as it is. Basically, we don't have enough posts. We don't have enough computing posts and people who can actually work on these products. If we did have enough people, we would potentially look at it in more depth, but certainly there's more than enough work to be done in-house without collaborating on other people's projects as well, as much as we would like to, and as much as I think it would be very beneficial to everyone involved, unless someone high up at NHS E&I, whoever they are now, NHSX or digital, unless they make a move to actually set up a specific department or to put in an infrastructure where people can collaborate and get some sort of funding for staffing. I can't see it actually happening.
Yeah, no, that's really helpful, really interesting. We'll probably stop there now so that we do finish. We're slightly over time, which I apologise about. Thank you to all our 4 speakers for speaking today. It's been really interesting to hear what you've had to say. Just a quick reminder that in September, we've got the in-person Clinical and Scientific Computing Symposium, which we would love you to come along to. So that's the 20th September, and which you can book, I think, on the IPM website now, but also abstract submissions are open, and they're only open for another couple of weeks. So the 10th of July is the abstract deadline. So if you've done any kind of computing work within your department, whether that's kind of research or clinical, we'd be really interested for you to submit a submission for an abstract submission for that. So please do submit. So thanks again to all the speakers, and thanks everyone for coming along.